Welcome to SST College of Arts and Commerce. This is SST Edupedia. Myself, Assistant Professor Yogesh Patil from the Department of Information Technology and Computer Science. Today we are going to discuss the topic analog transmission, first part, which is for class SYBSc. For IT, it is for semester 3rd, and for computer science, it is for semester 4, and the subject is computer networks. So let's discuss about the analog transmission. So analog transmission is nothing but we are converting the data, digital data, to an analog data. So it is also known as an digital to analog conversion. So digital to analog conversion is nothing but the process of changing one of the characteristics of an analog signals based on the information in the digital data. So in this session we are going to discuss aspects of digital to analog conversions, then the types of digital to analog conversions, that is ASK, nothing but amplitude shift key, FSK, that is frequency shift key, and PSK, that is phase shift keying. So what is analog to digital conversion? Digital data needs to be carried on an analog signal. So a carried signal, that is nothing but based on the frequency Fc, performs the functions of transporting the digital data in an analog waveform. So the analog carrier signal is manipulated to uniquely identify the digital data being carried. So as you can see in the diagram, when we transfer an data or a digital data which is in a form of zeros and one through a link or a common transmission medium to the receiver, then the modulator changes the data, digital data, to an analog data signals, and these signals has been carried out by the link, and then at the receiver end the demodulator receives the signals, analog signals, and it demodulate or convert analog signal to the digital data, and it has been received by the receiver. So how many types of digital to analog data transmission? So digital to analog conversion, there are three basic types, that is nothing but an ASK, FSK, and PSK: amplitude shift keying, frequency shift keying, and phase shift keying. So we have to keep one note that a bit rate, that is n, is a number of bit per second. Bound rate is nothing but a number of signals elements per second, that is nothing but an bounds. In the analog transmission of digital data, the signal or a bound rate is less than or equal to the bit rate. So as you can see, the formula says that S is equal to n into 1 upon R bounds. So where R is nothing but the number of data bits per signal or a signal element. So this thing we have to keep in mind to solve the different example or to calculate the data conversion rate. So let's see one example. If an analog signal carries 4 bit per signal element, and if 1000 signal elements are sent per second. So I repeat, an analog signal carries 4 bits per signal element, and if 1000 signal elements are sent per second, then in that case we have to find the bit rate of that particular channel. So let's see the solution. In this case, here R is nothing but the 4, that is analog signal which has been carried per signal element, that is 4 bits. Then S, that is channel, is nothing but we have carrying 100 signals elements per second, and n is unknown because we are trying to find the bit rate. So we have already seen the formula, that is S is equal to n into 1 upon R. Let's convert it for calculating bit rate, that is n is equal to S into R. So it will be 1000 into 4, that is 4000, and the unit for bit rate is nothing but an BPS, that is bits per second. So it will be 4000 bits per second. Now let's discuss about ASK, amplitude shift keying. It is implemented by changing the amplitude of a carrier signal to reflect amplitude levels in the digital signal. For example, if a digital 1 could be affected the signal, whereas digital 0 would be making it 0. So the line encoding, while determining the value of the analog waveform to reflect the digital data being carried. So as you can see, bandwidth of the ASK, that is nothing but it is proportional to the signal rate, that is S. So B is equal to 1 plus D into S, and here D is due to modulation and filtering lies in between zeros and 1 only. So let's see the diagram. As per the diagram, as you see, it is a diagram for binary amplitude shift keying, where you can see the different signals or digital signals which have a bound rate of 5. So we have 5 basic bits, that is 1 0 1 1 0. So this 5 bit rate, as you can see, whenever it comes to the 1, the signal, analog signal, is modulated. You can see the waveforms in the 1 session, and if it converts to the 0, the signal element or it giving a 0 value, and it carries to the further element as well. When we try to implement a binary ASK, as you can see, the modulation which has been carried by the carrier signal or a modulated signal, it always try to convert into a digital signal, or a digital signal always we are try to modulate into a analog signal, so we can easily transmit this signal through the transmission medium. So multiplier or oscillator has been used, or a modulator has been used for converting digital data to the analog signal. Let's see one example. If we have an available bandwidth of 1000 kilohertz which span from 200 to 300 kilohertz, and we have to calculate what are the carrier frequency and the bit rate if we modulated our data by asking using ASK with D is equal to 1. So let's try to find the solution. The middle of the bandwidth is located, that is 250, because we have span of 200 to 300 kilohertz. So middle span is 250 kilohertz. This means that our carrier frequency can be at F is equal to 250 kilohertz. Now we can use formula for bandwidth to find the bit rate. As we know the formula, that is B is equal to 1 into bracket 1 plus D into S. So let's put up the value. So S is nothing but N into 1 upon R. So it will be a 2 into, because D having a value 1, so 1 plus 1 2, so 2 into N, that is nothing but it is equal to 100 kilohertz. So the N will be 50 kilobits per second. Let's discuss about the frequency shift keying, that is nothing but an FSK. So here the data or a digital data stream changes the frequency of the carrier signal. For example, a 1 could be represented by F1 is equal to Fc plus delta F, and A or 0 could be represented by the F2, that is Fc minus delta F. So as you can see, we have already seen an amplitude shift keying, or in ASK the data has been, or a signal is modulated at a 0 level when it comes a binary 0 value, but in FSK the frequency has been changed. As you can see, signal 1 element which carries 1 as a value, binary value, it has a highly dense frequency, but at 0 it's fair enough and it carries to the next signal as well. So as you can see, the different frequency we have at the signal or a bit 0 and 1. So the bandwidth of FSK, if the difference between two frequencies, that is F1 and F2, is 2 delta F, then the required bandwidth B will be B is equal to 1 plus D into S plus 2 delta F. So here we are just adding 2 delta F value into the bandwidth of the ASK also. So let's see the example. We have an available bandwidth of 100 kilohertz, which is span of 200 to 300 kilohertz. This example is same as the previous example, and what should the carrier value, the bit rate, which has been modulated our data by using FSK here with the D is equal to 0. So this is the same example we have seen previous. So let's go to the formula directly. B is equal to 1 plus D into S plus 2 delta F. Here the delta F would be a 50 kilohertz. So let's add this value. So it will be 2S is equal to 50 kilohertz, which is nothing but S is equal to 50 kilo bound, that is N is equal to 25 kilobits per second. So now let's discuss about the phase shift key. So in a phase shift keying, the phase of the carrier is varied to represent two or more different signal elements. So here as you can see, the both peak amplitude and the frequency remain constant. So in the binary PSK, we have only two signal elements, one with a phase of 0 degree and other with the phase of 180 degree. So as you can see in a diagram, so the amplitude showing or first sine wave showing, it is starting with the higher value if the signal is 1, and it is starting with the lower value if the signal is 0. And the bandwidth of PSK, if the PSK is less susceptible to the noise than the ASK, it is superior to FSK because we do not need two carrier signals. And the implementation of PSK, the signal element with the phase 180 degree can be seen as a complement of a signal element with the phase 0. So it is just like a replica of the signal which has been come after conversion of 0 or 1. So thank you friends.